All right, so welcome. Today we're going to be looking at geometric transformation. That's what we're doing today, geometric transformation. And as we're looking at geometric transformation, all right, there are 4 types of geometric transformation. All right, just to go to the white screen, there are 4 types of geometric transformation. Number 1 is translation. The next one that you have is enlargement. Then you have rotation. And then finally you have reflection. So we're going to take a delve off into each of these today. So we're going to start with translation. All right, so let's look at translation. Now I brought us here because I want us to see exactly what happened. Let's say we're going to create a polygon. I'm going to use a triangle because oftentimes it's a triangle on the exam. So if I were to create a triangle, this here, I'm creating a triangle. And we can see the coordinates of each of the triangles. So I'm just going to change everything to units because I want the coordinates in units. If I were to show you this right here, the coordinates of each, I'm just labeling okay, I'm just going to show the coordinates. So coordinate, I need the coordinates of A is 5, 3. Coordinates of this point B is B is 5, 8, and C, which we know is 8, 3. I'm just putting on the coordinates for each of them. All right. Now look what happened. We're going to translate it. So I'm going to press on this diagram and click on transform. I'm going to translate it. I'm going to translate it not by any angle, but by a fixed distance. Now you might wonder, what do I mean by fixed distance? Look at this. If I put 5 centimeters, notice you see the triangle move over by 5 centimeters. And when I have a 1 down here, say notice it move up by 1. Let's say I put 0 here, so notice it just go across by 5. If we put 10 here, so it go across by 10. And if we put -3 right here, so it go down. So, so what are we quickly realizing? Translation, when we have the fixed distance horizontally, in vector form, they're gonna write it in vector form, translation vector. So let's just translate it. This is 10 minus 3. So right here, so we'll go from this triangle to this triangle by a translation vector t equal 10 minus 3. This is just an example to explain transformation. Now what happened? Why do they use the word translation? Translation as it means translate, moving from, all right, shifting from here to here. How did it shift from here to here? The 10 right here, the 10, when it's a positive 10, it means that it is shifting to the right. Remember that when you have a graph, going to the right is positive and going to the left is negative. So if this value was negative, let's use an example of when it was negative. If I were to translate it with a vector of -10, notice that the triangle gone over there, so. And if I did put a +3, notice it move up here, so. So this translation vector right here, what happened? This translation vector, we can call this maybe P. This translation vector P is -10, 3, as we just saw a while ago. Why is this -10, 3? -10 because we move the original triangle to the left, but going to the left is negative, going to the right is positive. Now, the first value in the translation vector corresponds to going across left or right. The next value in the translation vector is whether you're going up or down. If it is a positive 3, notice that the point A moves up by 1, 2, 3, positive 3. So this would be the A complement there. But when it's a negative 3, it means it shifts down. So notice that this is the complement here. So let's write that down. So just writing down now what happened. So first thing we realize is that translation is the shifting of an object given by a translation vector, and the translation vector that is most popularly used is T. This is the translation vector most people use, T, where T is equal to AB. And what does this AB mean? It means that the object moves A units to, it moves A units to the right, and that is if A is positive, it moves A units, A from right here, it moves A units to the right and put in bracket if A is positive. And then it would move, positive spelled wrong. It moves A units to the right if A is positive, and the object moves B units upwards if B is positive. Now, if this was a negative value right here, then what that would mean is that the object moves A units to the left if A is negative, and it would also mean that the object moves B units to or downwards if B is negative. All right, so that is what we have, and that's all you need to know with translation. All right, so of course we're going to do some we're going to do a couple examples of translation, and we shall see. The next one right here now is enlargement that we're going to look at. So that's translation. Let's go to enlargement. So now we're going to go for a new sketch. I'm going to go to graph again. Now we're going to look at enlargement. Now, what does enlargement mean? Probably make bigger or smaller, don't it? Now, let's say I construed a triangle again. This is my triangle that I'm constructing. All right. And let's say now this is my triangle, but I don't like this triangle. I just want to magnify it. So I'm going to go to transform. I'm going to go to transform. Oops, I got rid of the triangle by mistake. Let's go again. So this is my triangle I have, and I'm going to go to transform, and I press dilate. All right, now I want it to dilate. I want it to dilate about center A. No, I want it to dilate. This is not giving me that option. I want to magnify it, not by 1/3. Let me change it. Put the denominator as 1. Put the numerator as 5. Look at this. If I press 5/1, or maybe 2/1, notice the triangle doubles its size. 3/1, double its size. 4/1, 4 times the original. If I did have 1/2, notice this image is half the size of this, no? Look like it half it, no? And if I put 2 right here, so it look like it double it. Looking like. So let me fix that and put. Let's see how they put. Like that. So I put that it is 4/2 for the enlargement or the scale factor. They might say, what is the scale factor? Scale factor is just how much we enlarging the triangle by. So by a scale factor of 2, notice that this happen. Yeah, man. So this is what we notice happen. We'll use a scale factor of 2. All right, this is what happened. So this right here, so is the object. This is the object. This one is the object, and right here, so this one is the image. So now we're going to make some notes about enlargement that are extremely important that we need to know about triangles. All right, and not just triangles, just in general, geometric transformation. So the first thing is that we need to talk about the center of enlargement. We need to talk about now what is enlargement. We need to talk about scale factor. Then we need to talk about area of the image and area of the object and how they relate to each other. Those are all you need to know about enlargement. So the first thing is that, as we can quickly realize, we have these two triangles right here. This right here so is the object and this is the image. If you were to observe the length of this side, right here, the length of this side would be 1, 2, 3, 4, 5. The length of this side is 5. Then observe the length of this side right here. The length of this side right here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Length of that side would be 10. All right. Likewise, if you were to measure the length of this side, right? Let's measure that length. That length is 4.97. Let's just say 5. This length is 5. And if you're to measure this length right here, I guarantee you're going to get 10 or 9.94, something of that sort. If you measure that line, we get, see it there, 9.92. And that's because I don't extend the line fully, come up here to make it give me the 10 and extend this out fully to give me the 5. But really and truly what this is just telling us is, as you can clearly see, that this distance right here, this one is double this one up here 10 is double this, and the same way the hypotenuse is going to be double this. Now what does that mean? That means that if you're to divide the side of the image, if you divide any one of the side of the image by any one of the side of the object, you get what is known as the scale factor. So the scale factor is generally called a K. This is a scale factor. We generally call this the scale factor. And it's equal to any side of the image divided by any side of the object. Any side of the image divided by any side of the object. That's the first thing that we need to know about enlargement, is that it's a scale factor. Any side of the image over the corresponding side of the object. I shouldn't have said any side. All right. So it have to be corresponding side. So any side of the image divided by the corresponding side of the object. So this is how we find the scale factor. 10 divided by 5, 10 divided by 5, hypotenuse of this one divided by hypotenuse of this one will give us one number. That number is a scale factor. Now, the next thing we need to know, guys, which is extremely important under enlargement, after we find the scale factor, is finding the center of enlargement. To find the center of enlargement, what you do is you draw a line that connects, you draw a line that passes through the image and the object. So for example, the image of this point, this is the object C, right? This point right here, so is C. I'm gonna label that as C. This part up here, so is C prime. All right, this part right here, so is C prime. So label a point. We're gonna call it C prime because it is the object, it's the image of C. So if this is the image of C, if you're to draw a horizontal or a line, just as any straight line passing through C and C prime, look what happened. This is a line passing through C and C prime. All right? We're just trying to extend the line a little bit. This is the line. All right? Now, if we were to draw another line passing through this point B and D, where D is the image of B, if we draw one line passing through two of them, then likewise, if we draw a line passing through E and C, wait, so that is having some technical glitches. But if we draw this line now passing through E and C, notice that all of the lines them are gonna link up somewhere. The point where all of these lines intersect is going to be the center of enlargement. So I'm going to extend all of them and show you where they're linking up. In this case, it's linking up at the origin. All right, all of them going to link up at the origin when I show you. And then this is going to be the center of enlargement. As you can see in this case, the center of the enlargement is going to be the origin. Not all the time it's going to be the origin. It's just a case where we'll construct all of the line them together. In this case, center enlargement at origin. All right, so just to write that in words, the center of enlargement the center of enlargement can be found by drawing lines passing through the image and the object. That is how we find the center of enlargement. All right? That's all we need to know. And then finally, the last thing we need to know about enlargement is that there is an equation that you must know, which is related to the area of the two. And it goes like this: the area of the image, so the area of this triangle is the image of this triangle, which is the object. The area of the image is equal to k squared times the area of the object. Area of the image is equal to k squared times the area of the object. Now, just to prove it to you, mega spacer now and take this triangle. I'm going to take this triangle and show you the area, measure area. This area is 50.81. I'm going to take this triangle and measure area. This triangle now, measure the area. It's 12.7. Now look at this. I'm going to open up my calculator for a second. So here's my calculator. Look what I'm going to do. 12.7 multiplied by k squared. What was k? K was 10 divided by 5, which is 2. So that's 2 squared. When I multiply them, notice I get 50.8. What is 50.8? Area of the image. So see the area of the image, 50.8, is equal to area of the object times k squared, or k squared times the area of the object. That's all you need to know for enlargement. The next one now to talk about is rotation. And the best way that I like for us to remember rotation is there are popular rotation that will come on the exam, like 90-degree rotation, clockwise, anti-clockwise, and other type of rotation. This is the most popular one, 90 degrees, clockwise, anti-clockwise. All right. And these sort of things will come, but how I like for us to remember rotation is to just remember this thing right here. So I'm going to put a graph. All right. How I want us to remember rotation is to just remember this formula. This is all you need to remember for rotation. The rotation of theta is equal to, just remember this one formula, you don't need to remember nothing else with rotation. It's the cos of theta times the sine of theta well, not times sine, it's a matrix right here. Cos theta, sine theta, minus sine theta, cos theta. This is going to give you what is known as the rotation matrix. This is a rotation matrix. So no matter what theta is, you can find out what the rotation matrix is. Instead of having to swat all of them and then deciphering which one is which one, when is it a 90-degree clockwise, when it is 90-degree anti-clockwise, just remember the rotation matrix. This is a rotation matrix, R of theta is cos theta, sine theta, minus sine theta, cos theta. And whatever theta is, let's say you wanted theta to be 90. That would mean that 90 degrees clockwise. Clockwise is positive, and then minus would mean anti-clockwise. So let's say you want R of 90 degrees. You put theta as 90 degrees. The cos of 90 is 0. The sine of 90 is 1. Minus the sine of 90 is -1. The cos of 90 is 0. So this would be the rotation matrix for 90-degree clockwise rotation. This is the rotation matrix for 90 degrees clockwise rotation. That's all we really need to remember. Just remember this one little formula and you set. One formula you need to remember and you set. Yeah, man. That's all we need to remember. This is the rotation matrix. And we put a box around it. Just remember this formula right here and we set. All right, now that that is a rotation matrix, there's one final one that we need to know, which is reflection. And there are typically 3 types of reflection that will come: reflecting in x-axis, reflecting in y-axis. Then they probably ask you to reflect in the line y equal x, or maybe they ask you to reflect in the line y equal to -x. This is also a possibility. Or maybe they ask you to reflect it about a point. Now, in order to understand reflection, you're going to understand it when we do a lot more examples. So with that being said, let us start the example worksheet. So now we're going to go to the questions. All right, so now we're at questions now, and we gear up and we're ready to go. Now, this question right here, so what it says is copy triangle ABC and triangle A prime, B prime, C prime. We don't need to copy it, we already have the diagram right here. And it tells us that we need to locate the center on the graph and write down its coordinates. To locate the center of enlargement, all we need to do, again, remember, is draw one line passing through B and B prime. So I have to make sure your line straight. Draw one line just passing through B and B prime. You're going to do the same now for A and A prime. Draw one line passing through A and A prime. And you have to extend the line. Extend the line. All right. Then you draw one line from C and C prime. Pass through the 2 of them. Now, where all of the lines intersect, that is the center of enlargement. So in a case like this, the center of enlargement is right here. So all of them intersect. So based on the graph that have an x value of 0 and a y value of 4. So to tell them the center of enlargement is when x is 0, the y value is 4. Now the next thing they want us to do is to find the scale factor. To determine the scale factor, remember I tell you it is one side over another side. Yeah? So we need to find the length of, you can use anyone you want. You can use maybe the length of, maybe AC over A prime C prime. Or maybe you can use AB over A prime B prime. That's how we find the scale factor. Now looking at this diagram, as you can see, you can't just look at it and say, that the length of A to C, well, the length from A to C is 1, 2, that look like 3 units. So the length of AC, I'm going to write it right here. So the length, so I put the modular symbol. The length of AC is 3. And then now the length of A prime, C prime, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of A prime, C prime, that's equal to 9. So that means that the scale factor is corresponding side. Remember, it's the length of the image over the object for their corresponding side. So in this case, we can tell them that the scale factor, we like to call the scale factor K. So the scale factor K is equal to the length of A prime, C prime, length of A prime, C prime, divided by the length of A over C. And that is 9 over 3, and 9 over 3 is 3. So that is going to be the enlargement 3. Enlargement is 3. Now the next part of this question says, given that the area of triangle A prime, B prime, C prime is 36, what's the area of triangle ABC? To find the area of triangle ABC, what you're going to use is that area of the image. Remember this formula we just said a while ago? Area of the image is K squared times area of the object. So area of the image is going to be K squared times the area of the object. K squared times area of the object. Area of the image is 36. K squared is going to be equal to the scale factor square times the area of the object. So now to get the area of the object is going to be equal to 36. See it now, 36 divided by 3 squared, which is 9. So the area of the object is 4. That's it. The area of the object is 4. Now, of course, you can't just write 4. You have to write 4 centimeters square. That's the area of the object. Now, what if you don't believe me? You say, sir, I don't believe that the area of the object is 4. So what I'm going to do is actually create a triangle in the geometer sketchpad and show you so everything will look correct. All right, so let's go to the GSP5 again. And I'm going to show you that everything we did is correct. So what I'm going to do is actually construct a triangle. I'm going to construct my triangle just like this one. So remember, A is the point. A look like the point 2, 4. So A is the point 2, 4. We're going to insert that. So we're inserting in, plot the points, A being 2, 4. This was A. We're going to insert the point B and C. B was the point 3, 7. So B is the point 3, 7. Then we're going to plot the point C. C is the point that looks like 5, 5. C is the point 5, 5. Now we're good. So now this is triangle ABC, right? This is triangle ABC. So I'm just gonna, of course, do this now. And I'm gonna label these points. I just wanna label the point then. Label the plotted point, label as A, label as B, label as C. So now that is triangle ABC. Now I need to get my image now. So to get my image, just bringing over the graph a little bit. Bringing over the graph all the way over here. This should be fine. Now I'm going to insert the image points now. The image points was A prime is 6, 4. That's 6, 4. Plot the points, 6, 4. Then I'm going to plot the point right here now, which is B prime, which is, that's 5, 6, 7, 8, 9. This is 9, 13, 9, 13, 9, 13. And then lastly, the next point now, which is C prime right here, so is 10, 7. So plot 10, 7, 10, 7. And after I plot these 3 points, I'm not even going to label them. I'm just going to, I'm just leaving it like this. Wait, why is this like this? This is not 10, 7. All right, so I need to plot that over. I need it to be 10, 7. Plot points, I need 10, 7, 10, 7. That's 10, 7. All right, so now I have the 3 points then, so I can create my image now. Why does this look like this? This don't look like B. B is 9, 13. B was 9, 13. This don't look like this. Something off with this. So let me go back and look, see what we did off there. C is 10, 7. 10, 7 is right. B is, oh, C is not 10, 7. C is 15, 7. 15, 7. Okay, we plot this wrong. So let's just go back, take that back. 15, 7. 15, 7. All right. Now that we're good, now we can create up a triangle. So we'll do this, dum, 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 that is that. Now remember, we wanted to show that this right here, so, is double this area. So now what we're gonna do first is measure this area. Measure, remember, so we get 4 in a box cover. No 4, we did work it out and get. See it there? We did get to the area of 4. And the reason why it is true is because area of the image is k squared times area of the object. That's why we have to know this. And the area of the object they gave us was 36. The area of the image they gave us was 36. And so the area of the object is 4, which is true. That's what we got. And we can actually verify that the area of the image was indeed 36. This what them give you. If you did actually just click on it, we're going to click on it and measure it. See there, this is exactly 36 for true. So yes, guys, those are all the stuff you need to remember about enlargement. All the stuff, and that's it for enlargement. Literally, there's nothing more in enlargement. It's that easy, soft. All right? So you just need to remember scale factor is you take one of the side of the image and divide it by the corresponding side of the object. So it could have been A prime C prime over AC, or it could have been A prime B prime over AB, or it could have been B prime C prime over BC. That would have still give you scale factor. Center of enlargement is found by drawing bare lines passing through the image point and the object points. Where all the points connect or where they meet, that's the center of the enlargement. And that's all you need to know for enlargement. All right, so now we're gonna just look at this one right here now, which is some more. And this one now involves the others, which is, translation, rotation, and reflection. So this question right here says the diagram below, not drawn to scale, shows triangle LMN and its image O after a transformation. Copy it in our graph book. We're not going to copy it in the graph book. Let us say write down the coordinates of n. To write down the coordinates of n, we look at the x value where n is at. X value is 4, and we look at the y value, which is 5. So we can tell them, say n right here, so is the point 4, 5. There's nothing more to it. So we can put that n is the point 4, 5. Now that we have n is the 0.45, it says on the grid, draw a triangle FGH, which is a reflection of triangle LMN in the y-axis. So we need to reflect triangle LMN, this triangle. Draw a triangle FGH, which is a reflection in the y-axis. Now, what is the y-axis? I'm just going to use a red line to show you the y-axis. This is the y-axis right here. Now, remember, I didn't spoke much on the reflection in terms of what you should know. But guys, this is reflection. This is all there is to reflection, right? If I'm reflecting something, the orientation of it will change. All right, and the distance from the mirror line of the image and the object will be the same. Let me explain what I mean using this example. So from the mirror line to L, that's separated by 2 units. So that means that L prime is going to be 2 units away from the mirror line on the left. So this is going to be L prime. Right here, so it's L prime. I'm just going to do the same now. M is 4 units on the right. So M prime going to be 4 units on the left. So this would be M prime. Right here, so now N is 4 units to the right. So N prime will be 4 units to the left. That's all is reflection. Reflection is just that the image and the object, they are equidistant from the mirror line. Both of them are equidistant from the mirror line, the image and the object. So this is going to be triangle FGH. So don't label it N prime, M prime, L prime. It should actually name FGH. FGH. So I'm put the F where the M prime is. Well, L, so it would have been right here. So it's F, this is G, this is H. That's what it want we name them as. All right, nice. So we draw that now, and let's hear what they want next. The next thing that they want is, let's say, using vector notation, describe the transformation which maps LMN onto PQR. Notice that to go from LMN to PQR, it is being moved down. It's like we push down the triangle down here. So just say, go down there, so boy. Right? And it moves down by L, go down by 1, 2, 3, 4, 5, 6. So it shifts down by 6. It goes down by 6 units. So I put the arrow to show that it is going down by 6 units. It's not shifting to the left or to the right. So that means this is how you'd write the translation vector. T would be equal to 0, 6. That would be it. So of course, you need to write it out in words what that means. You need to tell them that it is mapped on by a translation with translation vector 0, 6. So we can tell them LMN is mapped to PQR by a translation T with translation vector and there you have the translation vector that I put right there. So T being 0, 6. All right. So I know this part should have come after. This T equals 0, 6 should have come after. All right. With translation vector, T being equal to 0, 6. All right. So that's it. Now the next part of the question, it says copy the following statement. It says triangle PQR is mapped onto triangle FGH by a combination of 2 transformations. First, triangle PQR is mapped to LMN by, so triangle PQR is mapped to LMN by a translation. So this first part is by a translation. So first it is mapped by a translation parallel to what? Now the x-axis, parallel to the x-axis. And then right here, so it says, then triangle LMN is mapped onto triangle FGH We know that already LMN is mapped to FGH by a reflection. In the y-axis. So reflection in the y-axis. That's it. We never do nothing right there, so. Then now it says triangle PQR and triangle FGH are congruent. State two reasons why. State why PQR, which is this triangle, is congruent to triangle FGH, this triangle. They are congruent because two of them would have same area. You can tell them that. If you were to work out the area of both triangles, remember say area, the area of this triangle, A1, would be half base times height. That would be half the base is 1, 2 units, half of 2 units times the height of 1, 2, 3, 3 units. So that end up getting the area of this triangle is 3. If you come down here, so this is 2 and this is 3, you'd end up getting that the area of this triangle is a half of 2 times 3, which would also give you 3. Yeah, area of this triangle is definitely 3. It's a half of PQ. PQ is 2 times the height of RQ, which is 3, and that is just 3. So the area of the triangle right there, so is 3. So both of them have the same area. Now, not only do they all have the same area, but if you were to measure the length of HG and the length of RQ, those are the same. If you measure the length of the hypotenuse of both triangles, those are also the same. So we can see that their corresponding sides are equal in length, hence they are congruent. So we're going to tell them their corresponding sides are equal in length, hence they are congruent. And the next reason was 2, because they have equal areas. The two triangles have equal areas. And that's it for this right here. Literally, there's nothing more for you to know about reflection and translation. All right, so translation is just shifting it across, either left or right, and reflection is either it's going to be reflected in x-axis, y-axis, about the line y equal x, or about a point. But what you need to remember with reflection is that if something is reflected, it is the image is going to be equidistant from the mirror line as the object. That's all. Question 2. Question 2 says J is 0, -1, 1, and it represents a single transformation. Determine the image of P and Q. So I'm just going to copy what is P and Q. Just going to copy P and Q and take it to the whiteboard. So if I copy P and Q and take it to the whiteboard right here. So this is P and Q. Wow, it brings up a telephone. That's crazy. P is a 0.54. And Q is the point 3 something. I don't know why it's giving me telephone. I know Q is 3 -37, but it's giving us telephone. That's crazy. So this is -3, 7. That's the point Q. And it's mapped under a translation J. Now this is what we do. In order to get what is the point P, what you're going to do, in order to get what is the point P prime is going to be equal to the transformation vector J multiplied by the point P. Remember, it's always a transformation first, then times the point. So P prime is going to be the transformation J they gave us is 0, -1, 1, 0, and you multiply it by P, and P is the 0.54. So this, to find what is the image of P now, you use matrices and you go row by column. Row by column, 0 times 5, which is 0. So 0 times 5 minus 1 times 4. That would be the element up here. Then the element down here is row by column. It's going to be 1 times 5 plus 0 times 4. So in this case, what we end up getting is that the image point P prime, is working out to be as a vector. You'd write it as a point minus 4, 5. But of course, don't leave it as a vector. Tell them so the point P prime is just minus 4, 5. Nice. And that's P prime. All right, nice. Now the next thing is they wanted the image of Q, meaning Q prime. You're just gonna do the same. What is Q prime? Q prime is equal to J times Q. So multiply the matrix J, the transformation J. The transformation J is 0, minus 1, 1, 0. I'll multiply it by the point Q, and the point Q is minus 3, 7. So multiply them, we know, so we'll go row by column. It's just going to be 0 times minus 3. Then the next element going to be, row by column, sorry. 0 times minus 3 minus 1 times 7. Close up that now. Then down here, so the next element going to be 1 times negative 3 plus 0 times 7. And that's it. We end up get what is the image Q prime. So what we're going to realize is that Q prime as a vector is going to be, that's negative 7, 3. Negative 7, negative 3, sorry. All right, but you don't leave your answer in vector form. Always write back your answer as a point. So Q prime is negative 7, negative 3. That would be Q prime. And that's it for this question. That's part A. Now this question right here says we need to take out our graph book. So I'm going to take out our graph book. All right, I'm going to go open a graph book. GSP5, that's our graph book. Our graph book, nice though. All right. So see me open our graph book here. This is the graph book I'm opening. So, all right. So this question right here, it says triangle ABC has coordinates 1, 2, B is 4, 2, C is 1, 0. Draw the points, then draw A, B, and C in your graph book. So what we're gonna do, A is 1, 2. Sorry, not here. So see it here now. Just gonna go to graph. We need grid form, rectangular grid. A is the point 1, 2. So just gonna insert them. Insert the points, 1, 2. This is our point A. That's A right here. So then B is the point. B is the point 4, 2. So just gonna put in 4, 2 again. 4, 2. Plot that point, see B there. And then C is the point. C is the point 1, 0. So plot in 1, 0 now. 1, 0. So plot all of these points now, and this is what we end up have. This is the triangle we have now, okay? Nice. So now we're just gonna have to create our polygon. Zoops, zoops, zoops. Now our polygon is created. Now that we created the polygon, let's just label it. Label the plotted point, that is A. This is B. And this is C. Now that we label our triangle, we'll complete the first part. Now the next part says draw triangle A prime, B prime, C prime, which is the image of ADC with an enlargement with scale factor. It has an enlargement with center O. O mean the origin 0, 0, and a scale factor of 2. Now the first thing I want you to do is, I keep coming here, my apologies, we should be here. First thing I want you to know is remember say A is the point. A is the point 2. What is A? A is the point 1, 2. Not 2, nothing. A is the point 1, 2. So in order to get A prime, since the scale factor is 2, you're going to multiply A by 2. So that means that A prime would be 1 times 2 is 2. Then 2 times 2 is 4. So that's going to be A prime. All we do is multiply A by 2. So can we just put that in now and tell them, say A prime. We're going to plot this point A prime now. A prime is 2, 4. Plot points. A prime is 2, 4. That's A prime. Now that this is A prime, B prime is going to be multiply B by 2. B was 4, 2. 2 times 4 is 8. And then the Y value is 2. 2 times 2 is 4. So that's going to be B prime. So B prime here. Then C prime is C is 1, 0. So you multiply 1 times 2 to get 2. And then you multiply 0 times 0 to get 0. That is how you're going to get C prime. We're done. All we need to do now is construct the triangle. Doom, doom, doom. That's it. That's literally it. All right. Just label them now as A prime, A prime. Label this one now as B prime. And label this one as C prime. All right, so now we label all our points them, and that's it. This triangle is the enlargement of this triangle. All right, and also this verify that the center of enlargement is the origin. See there, if we draw a straight line passing through A prime and A, B and B prime, C and C prime, this is all of them meet up back at origin. All right, so good. We know that the center of the enlargement, we know so the center of the enlargement is indeed 0, 0. So next part of the question now, we'll complete part A and part B. It says the area of triangle A prime, B prime, C prime is dash times. Now remember, it is K square. Area of the image, always remember the formula. Area of the image, because A prime, B prime, C prime is the image. Area of the image is equal to K square. What is the scale factor? 2. So it's going to be 2 square times the area of the object. 2 square times dash. It's going to be 2 times, it's going to be 2 square times the area of ABC. All right, why did they put 2 dash here? Let's reword it. The area of triangle ABC is 2 times 2 than the area of triangle ABC. So let's rewrite it this way and write it as 2 times 2, the area of, it's K square. It's 2 times 2, oh, I see it now. We should put greater than or bigger, whichever word you want to use. It's 2 square greater than the area of the object. Yeah. All right. So that is that. All right. If you don't believe me, you can check it out. We already draw the triangle. May I tell you, say it is 4 times the area. The area of this triangle will just construct this image right here. So you see this triangle. You see this triangle? This triangle, yes, this triangle. If you measure the area, you get 12, and I'm telling you that it is going to be 4 times this area here. So see the 3, it's 4 times it, 2 times 2 greater than this. It is 4 times it because it stems from the formula area of the image is K square, the area of the object. Now it says draw a triangle A double prime, B double prime, C double prime with these coordinates. A double prime is 5 minus 3. So we're going to plot 5 minus 3 now. We'll plot in the points. So we need to plot We go to graph, we want to plot points. Plot the points, 5 minus 3. Plot, and then we need to plot the point B prime, and B prime is 8 minus 3. So we're going to plot 8 minus 3, and we plot that, and then we need to plot the last point C prime of 5 minus 5. 5, negative 5. All right, so this is what we have right here. So of course, we're just going to draw the triangle. This is A, B, C, double prime, prime. I said double, and then I said prime, prime. So I didn't need to set a prime, prime since I said double prime. But yeah, this is the A prime, prime. This is B prime, prime. This is C prime, prime. Nice. Now let's hear what them ask next now. Next thing them ask is describe fully the transformation that map ABC to triangle A double prime, B double prime, C double prime. Clearly, it's a translation. We go from moving from here so to here so. We translate it. How much did we translate it by? We move over. If you go from C to C double prime, you go 1, 2, 3, 4 units across, then 1, 2, 3, 4, 5 units down. So A double prime is mapped by a translation vector of going to the right is positive, so it's positive 4. Going down is negative, so it's negative 5. If you don't believe me, look at this. I'm going to click on this triangle, go to transform, translate with a translation vector being 4. This is 4. And then this is minus 5. Oh, it's moving this. That's crazy. It's not what we want to translate. This is what we want to translate. So transform, not rotate, cancel. We want to transform, we want to translate by a vector of 4 minus 5. Notice how we translate it. You see this one highlight? Notice, look at this. This is how we click on it now. I would say transform, translate by 4 minus 5. Notice that this highlight, because it will say, that is it. To go from here to here is by a translation of 4 minus 5. So go ahead and tell them that these two triangles, ABC, is mapped to A double prime, B double prime, C double prime by a, it's mapped by a translation with translation vector. It's mapped with a translation vector T, where the translation vector is 4, negative 5. That's it. Translation vector of 4, negative 5. Nice. That's it. Let's look at this question right here now. This question right here, give us this diagram right here, and it says, the diagram below shows a triangle ABC and its image triangle A prime, B prime, C prime after an enlargement. Copy the diagram and use graphical method to locate the center of enlargement. To get the center of enlargement, we're just going to draw the line from C to C prime, or the line passing through C and C prime. We're going to draw the line passing through A and A prime. We're going to draw the line passing through B and B prime. Whoops, whoops, whoops. So where's the center of enlargement? Where all the lines intersect, and all of them intersect right here. So the center of enlargement is 0, 2. That's the center of enlargement, 0, 2. So we can just tell them that the center of enlargement is 0, 2. See it here? Center of enlargement, I'm going to call it C. Center of enlargement is 0, 2. Next thing it says is, what is the size of the scale factor? The size of the scale factor is 2, but not just 2, but negative 2. How do I know scale factor? Scale factor, remember, is image. So I'm going to use CA over the object C prime A prime, right? Now, if we're referencing to go from C to A, you go down by 1, 2, 3, 4, 5, 6 to go from C to A. Now, to go from C prime to A prime, we're going up. We're going in the opposite direction from C prime to A prime. So this would be 1, 2, 3, but negative 3. Yeah, that makes sense. To go from A prime to C prime is 3, or from C prime to A prime is negative 3 since we started going in a downward motion. So therefore, what we can tell them then is that the scale factor is equal to 6 over negative 3, because we divide CA over C prime A prime over CA, and that's negative 2. The scale factor is negative because the orientation of the image, is opposite to the orientation of the object. So the orientation of the object. That's it. The scale factor is negative because the orientation of the image is opposite to the orientation of the object. It says the length of B prime C prime is root 13. So the length of this, wait, we had a bloopers right here. This is a blooper. Actually, this was the image and this was the object. It's actually negative 3 over 6. Just to flip a switch, this was negative 3 over 6. My apologies right there, because the image is this, A prime, C prime. The object is 3, 6. So the scale factor is negative a half. If the scale factor is negative a half now, it says what is the length of B prime, C prime? It says the length of B prime, C prime is root 13. Find out what is the length of BC. The length of BC, guys, is going to be twice this distance. Why is it twice this distance? Because the image is half of the object. So the length of BC is going to be 2 times of that. It's going to be 2 times the root of 13. That's the length of BC. Now, if you don't believe me, look at it. See BC here, a half of the distance of this right here. So it's 2 root 13. Let's say you don't believe me, right? And you want to work it out. Then you come to the triangle and you realize that this is the opposite. Adjacent AB is 1, 2, 3, 4. And so you can use Pythagoras Theorem to find out what is BC by saying BC is the square root of 6 squared plus 4 squared, right? And you said this is the this is the length of BC. Let's say you prefer to do it that way. Well, if you prefer to do it that way, fine. You put that in a calculator, 6 squared plus 4 squared. And we work that out, and what we get is 2 root 13, just the same. Finally, it asks us now for the area of triangle ABC. The area of triangle ABC is this triangle up here. The area of triangle ABC is this triangle up here, and the area is half the base times the height. So the area is going to be a half of the base, which is a half of 4, times the height of 6. Half of 4 times 6, all of that is 24 times half is 12. So the area is 12. That's the area. So the area of the object is 12. Area of the object is 12. Now remember, area is 12 units square. Now the next part says, what is the area of A prime, B prime, C prime? But first thing we know, so the area of triangle A prime, B prime, C prime is K square. It's the scale factor K square. So it's going to be minus a half square times the area of ABC. Let me write the minus half better. It's minus a half square, which is a quarter times the area of ABC, which is half square is quarter. So what we're saying is that this answer right here is going to be a quarter of 12, and a quarter of 12 is 3. In this case, we can say that it is 3 square units. If you don't believe me, you can measure the base, which is 2. You can measure the height, which is -3, or you want to say 3. So the area of this triangle will just be half of the 2 times the 3. Half of 2 times 3, not the same 3 that, yeah, because the area of the image is k squared times the area of the object, and that's it. So in this case, the area of the image is 3. All right. Now this question right here, so now it says the triangle OPQ is given in the diagram. What do we need to do? We need to copy the diagram. We don't need to copy it. It's already here. State the coordinates of Q. This is Q right here. So what is the coordinates of Q? Q is the point where the X value is 4 and the Y value is 1. So you can just tell them Q is the point 4, 1. That is Q. It tells us that the line segment PQ is mapped to P prime Q prime by an enlargement center O with a scale factor 3. Draw the line segment P prime Q prime. Now guys, as we just did earlier, P is which point? P is 2, 2. P is 2, 2. P is 2, 2. If P is 2, 2, and it is mapped by an enlargement with scale factor of 3, then all you need to do is multiply 2, 2 by 3. So that means that P prime would be 2 times 3 is 6. 2 times 3 is 6. So that would be P prime. All you do is multiply P by 3 to get P prime. So P prime would be 6, 6, somewhere right here. That's P prime. You do the same. Q is 4, 1. 4 times 3 is 12. And then 1 times 3 is 3. So that's 12, 3. Somewhere right here is Q prime. And then this is what we need to show. That's P prime, Q prime. And then we can draw the line segment P prime, Q prime. That's that right there. That is part C. Nice. It says triangle OPQ undergoes a reflection in the line y equals 0 to produce O prime, O double prime, P double prime, Q double prime. It says draw the reflection of O double prime, P double prime, Q double prime. Now guys, the enlargement part done, we reach part D. So first thing we have to realize is that this triangle, it is reflected in the line y equals 0. The line y equals 0 is the x-axis. This is the line y equal to 0. All right? So if we're supposed to reflect 0, 0 in this line, this is the mirror line. I'm going to draw the mirror line. So this is the mirror line. This is the x-axis, that's the mirror line. If you're reflecting 0, 0 in 0, 0, it stays the same. So this is going to be O prime, prime. Then now if P is right here, so P double prime is going to be 2 units across from the mirror line, which is going to be here. So this is going to be P double prime. If Q double prime is 1 unit from the mirror line, then Q double prime is going to be 1 unit from the mirror line across over here. So this is Q double prime. And that's it, you know, really and truly, that's it. That is how we find enlargement. So see it there? This is O double prime, P double prime, Q double prime. I will draw a triangle. And that's it. We'll finish. That's it. We reflect it in the line y equals 0, or reflection in the x-axis. That's it. Literally, that's it. Nice. So see it there, we'll finish. So that's just our review of transformation. I really hope this video was helpful. And if you find it helpful, just make sure to like and